Here we go. All right. So, absolute value functions. Okay. If you are going to go the calculator route, and like I said, you don't have to. I'll show you a couple of other options here in a minute. But if you go ahead, I'll pop this up here for a minute, and get to your y equals. Some of you still may be in dotted mode. That's not going to hurt anything. But if you're going to do absolute value functions on the calculator, make sure you're in y equals first. Then hit your math button here, right below alpha, right below that green button. We've played with the math one before here. Before we were doing things over and under num, or numbers. Now before we were doing greatest integer function, number 5. Well, we're not doing that now. Now we're doing number 1, absolute value function. So if you hit math and then hit enter on number 1, or just hit number 1, we get this ABS, which stands for finding the absolute value. Well, our mother graph, or our base graph, is the absolute value of x. So if I just type in x there, and then I go ahead and graph that, I get this big V-looking shape. Which again, absolute value, since it's going to come out positive, is going to end up giving me these V shapes all the time, depending on what shifts are and things. Now, if you want to see your specific points, because you like to be able to graph them that way, you always, once your graph is up, you can hit second graph, and your table will come up. But normally we like to start at 0 and look a little bit at both sides, because then I can see that this is symmetrical. I notice that -1 and 1 have the same y value. I notice -2 and 2 have the same y value, and so do -3 and 3. And that's always going to be the case anytime you're dealing with an absolute value. They're always going to be symmetrical. Now, did I really need a calculator to tell me that, though? Not really, okay? Because I know myself with an absolute value function, if I wanted to start at the middle and say, okay, I wanted to start at 0, I know the absolute value of 0 is 0. I know the absolute value of 1 is 1, and the absolute value of 2 is 2. And even if I go into the negatives, since absolute value is just a distance, it just continues to go and come out positive. And I could plot each of those points that I just made my chart out of. And when you're doing an absolute value function, typically you're going to want to do at least probably 5 points. Just because you want your point in the middle, your vertex, but you also want a couple of points to make sure everything is symmetrical. Now again, can you do that with the TI-83? Sure. Okay, you can just punch it in and it'll tell you. But for you to understand quickly how to get things, sometimes it's going to be faster just to do it this way. Okay? But that's our base or our mother graph. So when I do get down into problems like number 1 and I start to see numbers, hopefully you say, well, that kind of looks like when we were doing our step functions, the only difference was we had that funky looking one and we were shifting left and right with these. That's the same thing that's going on here. Just like before, that x minus 2, when it's inside the absolute value, means we're doing a left or a right shift. And in this case, it's going to be a shift to the right, too. It's going to be the opposite of what you think. And again, the reason for that, when you're trying to move around, is this is the actual mathematical form for an absolute value function. And you'll notice inside here it says x minus h. It's the opposite. So if I see this as minus 2, okay, the opposite would be a positive 2, or a right 2 shift. So here's how cool this works. I shift right 2. Since my mother graph starts at 0, I'm going to shift right 2. And then what did I do when I was up here? Well, basically, it looks like I went up 1 and over 1, up 1 and over 1. And just kind of did that just like I did with the stepwise functions. So I'm going to go up 1 and right 1, up 1 and right 1. To make my other branch, up and left, up and left. Now, if the whole idea of just putting in a shift right now isn't working for you, you're like, that doesn't quite click with me yet. Okay, here's your other option. Besides, you could put it into the calculator, okay? If I wanted to, I could say, okay, since I went right 2, my graph is starting at 2. I know the y value is 0. Well, duh, 2 minus 2 is 0. But then I'm going to take 2 points to the left and 2 points to the right. Whatever that initial point is, I always want 2 points to each side of it. And again, these are so quick. 3 minus 2 is 1. 4 minus 2 is 2. 1 minus 2 is negative 1, but again, this is absolute value, so it comes out positive. Because if I've done this right, if I've got that middle point of my graph, my vertex done correctly, my y values that are each 1 away and each 2 away should be the same. Okay, they should be a mirror image of each other. So that's why I'm saying with these, you don't necessarily have to have a graphing calculator to sit there and try to do something fancy. Because all we're going to do, what do you think this shift is going to be? Okay, negative 3 or left 3. So I go left 3, put a dot. And since there's no value in front of my x, there's no coefficient that's greater than 1, I'm just going to go up 1 and right 1. Up 1 and right 1. Up and left. Up and left. Okay, I'm just going to make that V shape in there that basically has a slope, if you wanted to call it that, of 1. And we just get that same V shape. You notice the width of it continues to be the same each time. As we go. And again, if you weren't sure, you can always put it into the chart, and you would just start your chart at negative 3 this time. So if you were going to do a chart, and I'll just get the initial part set up, negative 3 would be my middle, and I'd again, 2 values that are less, 2 values that are greater, and I just plug those in and plot the points. But either way, it's not going to matter that much to me, because any of them are going to be quick, even if I went to the plot points part of it. Any questions on the first couple? So I'm going to keep referring back to what we were doing before with the step functions and piecewise, because we're doing the same thing with our shifts. That's not changing at all. Okay? As long as we aren't changing that coefficient, we aren't in 3 or 4, the same rule is going to continue to apply. But now notice my pluses and minuses are outside the absolute value. So what types of shifts do you think those are going to be? Okay, they're going to be up and down. But they go exactly with what you would think. Because again, if I look at my format here, it's just plus k, and this is where we're getting it from. So whatever value I see in my absolute value function, whatever that shift is, I'm going to follow basically what I would think. And with this one, plus 2 seems kind of like it would be sensible. So I'm going to go up 2. I'm going to make my first dot. But then just like every other time so far, it's just like having a slope of 1. So I just go up and right 1, up and right 1, get a couple of dots. Up and left 1, up and left 1. Because again, it should look symmetrical. That's the dots. We're off and running. Now, some of you are like, well, wait a minute, though. If I'm a chart person, every other time it's been 0 so far. Well, this time, my x is 0, and my y changed value. That's true. But I'm still, once I get that middle point, I'm still going to take 2 values that are less and 2 values that are greater. And then I'm still going to just plug them in. 1 plus 2 is 3. 2 plus 2 is 4. The absolute value of negative 1 is 1. Plus 2 is 3. Absolute value of negative 2 is 2. Plus 2 is 4. And it's still symmetrical. If I've got the middle point right, it will be symmetrical every time. If I screw something up, I'll start to get different numbers, and I'll be like, wait a minute, something's not quite working right here. What will my shift be for number 4 then? Down 4, because again, once we're outside, let me bring this down a little, when we're inside the absolute value with our shift, that's left and right. When we're outside the absolute value, now we're up and down. So now we're down 4. There's my first point. And I don't have a change in my coefficient. So up and right, up and right. Same thing with up and left. And we're just getting that V-shaped function. Doesn't change in width, just moving around a little bit. Now it won't be that way forever. I mean, it never is. So if we bump up a little more, now we start seeing changes. Am I doing any shifts on number 5? No. Now, if you wanted to put a +0 there, you could, but it's going to be here at 0. But again, think of it like now I see this negative in front. Okay, basically, I'm going to take my mother graph and I'm going to flip it. Or I'm going to look at it like a negative slope. So instead now, with that negative, I'm going to go down 1 and right 1. Down and right. Or down and left. Down and left. The chart would still work here, except now that the negative's outside the absolute value, if I would plug it into the chart, then I'd have to change the sign. So for instance, if I went charting here, the middle point is 0, I know that. So I'm still going to have my 2 values that are less and greater. But when I go to plug it in, absolute value of 1 is 1, but there's a negative there. Okay? That negative lurking outside does change the sign to negative. Absolute value of negative 1 is positive, but the negative's lurking. And so I get those negatives to know that that value is going to come downward once I actually go to graph this. 6, same idea. Okay? There isn't a shift. So I start at 0. But what's my slope of sorts this time? 3, or 3 over 1. So I go up 3 and right 1. Up 3 and right 1. There it is. And again, symmetrical. Up 3 and left 1. So you'll notice if my coefficient changes and becomes larger, my graph actually gets skinnier. It kind of compacts itself. If I had a fractional number out there, it might start to get really, really wide. So that's kind of our whole idea with this, is we're looking at it kind of like slope, but we're getting these V-shapes everywhere. Okay? So, let's see here. Over here on the back, we actually do talk about that. Even though I'd had you write it up there above, there's something here that we can get something official with. When we're doing absolute value, my vertex, okay, my changing point, my starting point of my graph is what's called HK. Now you'll notice again, H is always going to be the opposite of what you see there. So if it's x minus 3, my vertex x value is going to be at positive 3. And then my slope, thank you. So then my slope is going to end up being whatever my A value is. If it's negative, we'll open down. If it's positive, we're going to open up. So as we start to do some of these, and for 7 through 10, I just want to do, except for, well, for these first couple, we're just going to do the vertex. Then we'll start graphing again. So vertex. Notice the form up here. You're like, well, I don't see this other stuff. This would be the equivalent of having 2 and then x plus 0 plus 0. When I don't see something, it's a 0. So then my vertex, in this case, would be the 0 that I have in here with my x, since I don't see one. The 0 that I see here. I'd be starting at 0, 0, just like I have been on all of these other ones so far. And then the slope of my branch is just whatever number's in front of the absolute value. And again, as we've been graphing all of these, up and over, you notice just like we saw in the last one, again, it's a little bit skinnier than the mother one is, but that's because we have a coefficient in front. So with that in mind then, what's the vertex going to be on number 8? Okay. 3, 0, because again, since my normal format is minus h, whatever sign I see here inside the absolute value is going to be the opposite of what I would normally think. So my vertex is going to be a 3, 0 because I shifted right 3. What's my slope of my branch going to be? It'll just be 1, or 1 over 1, because I don't see a number in front of it. Up and over, up and over. Those go out. So once you get the basics down, it makes life pretty simple. Well, what if I start doing multiple things? Then what the heck's going to happen? This could start getting tricky. Well, if we bump up and say, okay, so for number 9, what would my vertex be? Okay, 0, because I don't have anything in the absolute value, so it'd be like x plus 0 being in there. 4, because I do have the number outside. 0, 4. And then what would my slope be? 1/2, because I do have a coefficient in front of my absolute value now. So I'm going to go up 1 and right 2, up 1 and right 2, and then just do the opposite to make my v. Up 1 and left 2, up 1 and left 2. And when you get a fractional coefficient, you're going to get really wide graphs. The smaller the fraction, the wider the graph. But again, the whole key is having that starting point, knowing that my vertex is at 0, 4. All right, one last one here. Ooh, it's the first time we're getting the double shift going. What's my vertex going to be? -2, 1. Change the sign inside. Keep the sign on the outside. -2, 1. What's my slope? 1 over 1. So see, I don't have to be an expert with all of the fancy stuff here. As long as I understand the slope, once I have that vertex, go to the vertex and then just slope it. And I'm done. Okay, going both ways. So I'm hoping that's something that you're like, okay, I'm going to be able to live through this. We okay so far? On the next group then, we are only doing the vertex and the slope. Those are the 2 critical parts of this that we have got to be able to do. If we can do a vertex and a slope, these are easy to graph. All right, so 11, what's my vertex? 4, -2. My slope? 3. Or again, I'm just going to keep putting the over 1, and some of you are like, now why are you making everything a fraction? I've seen enough times that people make slope, they'll go up 3 and put a dot, up 3 and put a dot. I've seen all of these vertical lines everywhere. You put the 1 there, it just helps you to remind you, oh yeah, I got to go 3 over 1. Otherwise, this doesn't work so well. 12, vertex. -5, 3. Slope? -1 over 1. Because I see the negative in front, that tells me how this is supposed to be working. And again, once you get that vertex, you plot that one point, and then from there do the slope for a couple of points each direction. it makes life easier. When we get to 14, I want to actually graph that. So 13, what about my vertex? Negative 1, opposite of what I see inside. Negative 6. Slope? 1 over 4, whatever I see in front. You start to see this is basically like graphing regular lines. Okay, last one. Now I want to take a look at this one closer. What's my vertex on 14 going to be? Negative 3, 7. Graph that first. And then my slope is negative 2/3. Now remember, that negative 2 can go on either one of the numbers, but only one of the numbers. So I would just put it in my numerator. So I'm going to go down 2 and right 3. 2 and right 3. And then down 2 and left 3. 2 and left 3. That fractional slope gets us wide, the negative slope gets us opening downward. It's those little clues that you get that should help you to see whether this is working or not. And again, I can plug this in on the TI-83, but it's one of those things that I'm like, I can do it, but actually that slows me down somewhat. So now here comes the part that we get to apply it. Good time. What if they give you the graph and ask you to make the equation? We can handle this, okay? When I go to make the graph, we're just going to recopy that format that we had on the last page. And what we're going to be doing is we're going to be filling in values for A and H and K. So here's how this works. I need to write down where the vertex is. I need to write down the slope. Because when I do that, I'm going to have H and K, and I'm going to have my A, and then I can make the equation out of this. So again, do it in pieces. What's my vertex for this graph? 2, 1, because it's the point where it changes direction. Okay, so 2, 1. What's my slope? Okay, right. If I look, I can go between any 2 points that I want to. So I went down 2, and I went right 3. So my slope is negative 2/3. So when I go to graph and make my, I already have a graph. When I go to make my equation, I just look at this and I say, okay, here we go. So y equals, my slope is negative 2/3, x minus, h is the x value that I have here, plus 1. Because now if I look at this equation that I just made, my vertex is at, the opposite of this, 2, 1 matches. My slope is negative 2/3. And if I followed this, I would get this exact graph back. And that's how these are going to work. Bump that up a little bit here. Same thing here. You know your vertex, which is here at negative 2. And again, that's my H and my K values. My slope, Okay, 2 over 1, and some of you are like, okay, but I don't see the second dot. Remember, I can pick any place where kind of those crosses come up, okay, those intersection points. And then from there, you can always count, went up 2, I went right 1. So my slope is 2, or 2 over 1. And once I have those two things, again, just follow the form you have. y equals, my slope is my a, so 2, x minus 2 minus 2. Because again, I'm just following, it says x minus h, if my h is 2, I just minus the 2, and then I copy the flat. So that's what we've got working here. At the bottom of the sheet, you'll notice what we're actually looking at assignment-wise. Sometimes it's just telling what the vertex and slope is, a couple of them it's graphing, a couple of them it's coming up with this. But again, with this combined again, having some of you look at the, the piecewise functions and the step functions one more time is getting us ready for that. So again, this will end up being the last assignment that we have, I believe. I'll have to double check. But I believe this will be the last assignment for the homework check on Wednesday. So if you're a little behind on that, catch up a little bit. Okay? But otherwise, we'll have time to go over this and the quiz preview tomorrow before the quiz itself. The quiz itself should only take about 15 minutes or so. And we're good.